So today's video about centre of mass should be a nice simple introduction to the topic. You're already really familiar with the idea of centre of mass, even if you've never thought of it in a really rigorous physics way. And that's because the centre of mass can be thought of as the point through which the mass of an object appears to be concentrated or appears to act. It's related to the idea of centre of gravity, which we'll get to in a little bit. But you're really familiar with this idea. It's related to the concept that if you have, say, a ruler, if you put your finger in the middle of the ruler to hold it up, the ruler won't move. It'll be balanced at that point. You'll be applying a force, an upwards force, against its centre of mass, therefore it won't be turning. So for uniform objects, the centre of mass is usually in the middle, horizontally and vertically, in the centre of the object. Likewise, if you have an object like this, the centre of mass would be in the middle of it. The two, assuming that the weights on the end are uniform, the two weights are balanced in that middle point. On the other hand, when you have a non-uniform object like this one, and common examples would be like spoons or forks, anything like that, the centre of mass is not right in the middle of the object. It's concentrated towards one end. And so the centre of mass will be found somewhere along here, closer to the massive part of the object. Now, a little bit later, we're going to do some actual calculations to find the centre of mass of a complicated object. But we'll say, let's say for our purposes of today, our centre of mass is about there. We can also think of centre of mass in terms of the effect that forces have. So it's also the point where any force that you apply only leads to straight line translational motion. There is no rotational motion, no spinning. So you can see that if we had a ruler, for example, and we were holding it through the middle, it wouldn't go anywhere. Yeah? If we pushed it in the middle, it would just slide along in a straight line. On the other hand, if we applied a force at the end of it, we would get a spinning motion around the centre of mass. And this is why centre of mass is so interesting. Things pivot around their centre of mass. So if we look at our two rulers here, here's our centre of mass. If we apply a force on the centre of mass, the object will move in a straight line. There'll be no spinning whatsoever. On the other hand, if we take our ruler and apply a force at the top, we'll get a spinning motion. We'll get some rotation happening. Okay, there might be translation as well, depending on how you push it, but there'd be spinning. Okay, so basically, if a force goes through the centre of mass, you only get straight line motion. If the force is applied anywhere else, you get some spinning as well. So related to all of this is the idea of centre of gravity, the idea that if you concentrate the mass of an object at a certain point, that's also where its weight force is going to act. And we're really familiar with the idea of centre of gravity, the idea that some things will tip over and some things won't, or where you have to apply a force to tip something over, depending on its centre of gravity. For example, SUVs are really safe cars in general, but because they're so high off the ground, they have a relatively high centre of gravity, centre of mass. Therefore, they're more likely to roll in a collision than a car which is lower to the ground. The one that's lower to the ground might not be so useful when you're going off-road, but in a situation where there's a force applied at the top of the car or there's some kind of force applied from the side, an SUV is more likely to roll because it has a higher centre of gravity. And a little bit later again, we're going to do some demonstrations and some calculations about how that occurs.